All right, let's take another one. Good, thanks for your, you got one there. You got 2 or 3 there, but that's where you're gonna have to get them sharpened up. Okay, another one. Who's got one?
Does the ministry assignment component of the UrbanCAD program, a specific program, increase the number of individuals who serve within a local church ministry?
Okay, now, there's one fundamental problem right from the word go. Did you spot it?
Yes,
He formed a question. Now, that's an easy one to correct. All you gotta do is twist it around and form a statement, because a hypothesis is a statement of hypothesized relationship. And it usually is in the form of, if this is done or happens or is, an experience, then that. If this, then that. All right, what's your if? This is, the if is your independent variable.
If the ministry assignment component of the UrbanCAD program is present,
Has been experienced.
will it increase the number of individuals who serve within a local church?
Okay? Now, what's his independent variable? Again, we're back to an educational program. He's at least named a characteristic of it, however, which gives us a hope that we can pin it down, same way we pinned yours down. What's his dependent variable? Now, I couldn't make it out. Could you make it out, the dependent variable?
Number of individuals serving.
I don't think that's what you're driving at. It doesn't work in my mind. Give me a nominal size of the church. 300?
100.
100. Okay.
In my descriptive analysis, I do have a definition of ministry and service.
All right. So you're already talking about everybody, and you're talking about.
I'm talking about a specific group of people that are serving. Graduates from the program.
Okay, number
Some
one.
of them could be graduates from the program,
All right.
but I'm not necessarily eliminating graduates.
All right. See, the problem here is that he's got all of this group gets such and such. And then that will make something out here bigger or littler. The problem is if he's got everybody getting it, I couldn't understand how that's going to make any difference at all out here, other than I'm going to have some kind of a constant here. If 25 people take this program with this emphasis, 20% of them will be found doing such and such in the church. Okay, how do I increase that 20%? I've already shot the whole thing over here. What's supposed to be the variable?
Whether they have it or not.
Ha 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 ha. Okay. So then, many hypotheses that you're going to want to use are the presence of a phenomenon over against the non-presence of the phenomenon. Okay? For those who have taken the experience, a higher proportion will be doing such and such than for those who have not taken the experience. See, that's what I was saying. I couldn't hook it up because I was seeing this. And the problem is not in your head. It's a problem in the way you state it. And some of that is a matter of making sure that as you state the hypothesis, the if-then has within it all the pieces that are necessary to visualize that. Okay? All right, that's another one. Let's go for a third one. Yes?
By decentralizing the sermon and putting an equal emphasis on the rest of the worship liturgy, members of the congregation will value more their worship experience.
What's the independent variable?
By putting an emphasis on the part of worship that's not the sermon.
All right. What's the dependent variable?
The people in the congregation will value more their worship experience.
How will they indicate that valuing?
I have to ask them and find a way. They can name some worship items, things like that.
Okay, so it's actually then some kind of a opinion plus evidence of recall. So you have an idea. And what we have to do there is just make sure you thought through what you could do to get a handle on that. That's fine. Now, are you satisfied that that is a hypothesis and it could be tested?
You know, music is so different from week to week, and the sermon is different from week to week. How would you separate out the different quality of singing, the poor singer and the bad singer?
And of course, bad singers can't contribute to worship, and good singers always do. How do you like that one? Yeah, there's some real sticky problems here, but I don't think that's quite a fair rebuttal. That rebuttal sounds a little bit like, if people eat, they will be more healthy than if they don't eat. To answer that and say, yeah, but there's so much variability in food. I think in the general frame of it, you've got to look at that as a lot of research you've got to look at in terms of the uncontrollability of the pieces within the environment. But he's going to look and see what the consequences of that environment is. You know, they have established that if you put signs at the side of the road that show Smokey the Bear, people are less inclined to start forest fires. That's been well established. That the Smokey the Bear signs do make a difference. And the national forests that have used the Smokey the Bear signs have fewer forest fires. As simple as that. So there are, you say, good grief. There's all kinds of, even, in North Carolina where everybody smokes, you'd expect a lot more, oh man, it would depend on what state you're in, depend on what region, depend on what the smoking habits are, depend on, funny thing, it's the Smokey the Bear sign. So maybe he's got a Smokey the Bear sign kind of research going there. I wouldn't rule out the possibility. There are some interesting ways to sophisticate that, but let me tell you something. You are doing a 5-finger exercise. And that isn't very far from a workable exercise hypothesis. Let me tell you what I'm hearing in that, because I'm hearing everything I need. Because he has the possibility there for doing an experimental study, or more precisely doing a quasi-experimental study, and I'm going to save till tomorrow the details on a quasi-experimental, but that one is unnatural for a quasi-experimental study. Let me just share with you this much about a quasi-experimental study. There is a quasi-experimental study called, one of the species, called the time series study, which is by all odds the most useful. You want to study up on one of the designs, and you want one that's most useful. It's the time series, TIME-series, time series study. TIME-series, time series design. All right? In a time series design, you have a treatment that occurs at a certain point in time. And then you have another period of time, and you measure here, and you measure here, and you measure here. These are all equal periods of time, one period, one period. Now what am I going to see? Let's say that my measurement, which is the same measurement in each case, gives me, for a group, gives me a mean of 64. Then at the same time I do the treatment, at that time I do another, and I get 66. And over here, I do it again in the same period of time. This is, let's say, 2 weeks. And I do this treatment for 2 weeks, and I then measure, and I put an R instead of an O, forget my codes, watch myself here, and I now get a score of 81. Can you tell me what has happened? Time runs left to right. Now you read that chapter in the book. It's one of the chapters I asked you to please read. That is a classic time series study. Those are the scores that I get on this study of his, and I get them, and by golly, there it is. What are those numbers? Come on.
Shows that there's been a
change due to the intervention?
It shows that there's been a change due to the intervention. You are right, but how do you know that?
Because of the increase in the means.
So you're
Before and
saying,
after.
because 81 is bigger than 66, you're attributing that to this treatment. Am I right? And if indeed nothing else is going on that you can attribute it to, and you've checked that out, and you're pretty sure nothing else has happened, that's a pretty safe assumption. That's called a time series. Now, why do we need to do this one back here? To establish a baseline that says, look, you can give that test as many times as you want. You can expect scores right in through here if you don't do anything else. Is it the test that resulted in this, or is it the treatment? This is the treatment. Follow that? All right, now, here's what you could do. If you have an ongoing pattern of worship, and you can test it at 2 points in time without changing it, and find out what people remember, how well they liked it, what they appreciated, what they didn't appreciate, what it caused them to think about in terms of any kinds of variables in godliness and concerns, anything you want to throw in there, just do it twice. And if indeed your test is meaningful to the people, to the point where they can grasp what the questions are, they're not apt to give you wildly different scores, right? Now, it may differ more than the 64 to 66, but let's say it varies this much. It was 64 here, and it was 53 here. What do you think? Is that important? Sure, it's important, but what's it saying? Whatever this current thing is that's going on in the church, it's going up and down anyway. Right? Then what I'm going to do is I'm going to introduce a change, according to some kind of a plan, in the allocation of time, and then I'm going to reassess after I've done this to see how that change relates to the same items that I've used here before. Now, what happens if I get a score like 91? Now what? Now what? Now what? Now what? Come on, interpret that.
It seems to lift it above the standard, the regular zigzag.
Is 91 bigger than 53? Is 91 bigger than 64?
Yes.
So never mind what 63 and 64 and 53 are. This is a lot bigger. So whatever the variable is that's going on, you're getting a higher judgment or assessment of it here than you did back here. So again, it looks like that was a pretty positive change. However, the real world isn't like that. The real world isn't like that. Here's what you'll get. That's what you'll get.
Yeah.
Now what do you know? Pardon me? Apparently no or little impact, or whatever it isn't that much different from what was before. Here's one of the beauties of time series. See, I can keep adding to this and discover whether or not it looks like this. Now you tell me what's happening here.
Is having a negative effect?
It's going the wrong direction. See it? That's a real possibility. Now that doesn't thrill me because I really would like to see this hypothesis stand up. But I'm not in a political boat. I'm in an inquiry boat, and I am fascinated by the fact that this is not working out the way we predicted it. That fascinates me. And if you, as a researcher, can get fascinated, then you may learn something. But what we really hope to see, and of course I'd like to be able to tell you that this is what really happened. What really happened is you get about this, and then you get about this, and then you get 74, and now what do we got? By golly, it took a little while for it to catch on, but by golly, they're going for it. And I will tell you this, no matter what change you make in anything related to a church, your first measurements will be down. Almost always. Because in the real world of churches, churches are traditional, and violation of the traditions will draw everything downward. And if you can just wait long enough, you'll lose all those people, and then you'll... But that's a good research. But the point is, you proliferate the thing all over the place, and that's not going to help you. What you really need to do is to say, how can I build a particular research? You will find that the time series will work beautifully for that one. So stick with that one and try to nail down your variables, and wait till tomorrow when we get into time series design, and you'll see where it works. One more, we had one more, is it, wait a minute, were you the one? Are you sure? You just snuck in here. All right, go ahead. Did I leave somebody out?
I had raised my hand before, but mine was very similar to Michelle's.
I see, the mush ball, huh?
Yeah.
We'll come back to yours. All right, catch, let's go.
Okay.
Go further.
If you give him the award to become a Christian person similar, people that are in small groups will increase their acceptance of Christian values and beliefs more than people that are not in small groups.
All right, now the problem is that he's got a good experiment here. He says people that have this characteristic or are given this opportunity over against people that are denied that opportunity. That's also known as a white rat experiment. Why is it called a white rat experiment?
Because you're assigning the people?
I'm going to have to assign them. Same way I say, okay, little Mikey, you go over here, and, yes, Jerry, you go over here. I know my name, see, and I'm God, boy, I'm going to move those things around. Those white rat experiments are great if you're God. They're not if you're not. Because it's very difficult to go to real people and say, Charlie Brown, I'm going to put you in this group. Charlie Brown said, yeah, but the cute little girl with red hair is in that group. I want to be in that group. So Charlie Brown doesn't assign that easily, right? Okay. It's tough. It's tough to design that, but you're right. That is a hypothesis. So let's deal with it in those terms, and let's accept it. The point here is, just because you can make a hypothesis does not mean you can turn it into a research. But you've got to define a hypothesis. Do it again, and he's got a glorious hypothesis there, really a good one.
If you give him the award to become a Christian person, say like, people that are in small groups will increase their acceptance of Christian values and beliefs more than that they are not in a small group.
All right. What's the variable? What's the independent variable?
Being in small groups.
Being in small groups or not. The independent variable there is either an off or on phenomenon, okay? Yes, we're doing it, or no, we're not doing it. So it is being in a small group. What's the outcome, the dependent variable? What'd you hear?
Values.
Acceptance of Christian values. Now, is that measurable? Got a little bit of a problem here as to whether or not acceptability or acceptance or personal agreement or personal faith or personal statements or personal embrace is all that measurable. What you can measure is whether or not people make claims. You can measure claims. But that's, again, one of the reasons why human variables research is so ultimately difficult. And if you willy-nilly go around and say, well, I'm going to assign these people to this group and these people to this group, you have no idea what Sunday school people are like. To say nothing of trying to do that in the public arena. Because once people start breaking your assignment, they are going to break your study. Because if somebody comes to you and says, you know, you assigned me to the control group, I don't want to be in the control group, my buddy's in the experimental group, I want to be in the experimental group, oh, that's all right, I'll change you off with Fred. What have I done? I've ruptured the sampling plan. Very serious.
And how about if I use groups that are there? Well,
Intact groups, that's the term for it.
yeah.
Intact groups. An intact group is a group, take the group the way it is and put it against another intact group. Now what's the problem in that? I got two intact groups. I go to an elementary school and I take a group of sixth graders, an intact group of sixth graders, and another across the hall, sixth graders, another intact group. And I give these people, you know, elaborate amounts of sugar candy twice a day. And I give these people none. And sure enough, when I get all done, what's going to happen? The ones without candy are going to be very angry, and that's about all we can be sure of. That's about all we can be sure of. Because what we can't be sure of is whether the candy made any difference. Because if I end up and say, look, these people have finer scores for the year, I can't say a thing about it because I don't know that they wouldn't have had finer scores without the candy. I've got no way of knowing because there's no matching, no comparison. You just can't take intact groups. And that is one of the real reasons why doing experiments in the old-fashioned XOX model, or OXO model, is so unlikely to succeed. Now, before break today, I want to give you just one more shot at this, and this will help you connect. See, Ron, help you connect with the text. I'm going to draw you a picture. I'm going to tell you what some letters are, and then you tell me what I got here. Or better yet, you tell me because you've read the book. Do you know how to read that? That's standard nomenclature. It's called OXO. What is O? What is X? What is the signal called?
Observation.
O stands for observation. X stands for treatment, or in its actual origin, it stands for experimental treatment. Hence X. Not unknown, but experimental. Got it? It's a corruption of the idea of EXPER. Experimental treatment. All right? What does that as a whole symbolize right there? What is this meaningful sentence?
Comparison.
It is pre-test, treatment, post-test. That's what it is. Now that is sometimes called the standard experiment. Why? Now, what I'm driving at is that is establishing the baseline, doing the thing, and then seeing what this is in contrast with this. Now, when we first threw that up, there's several of you muttered something about it allows you to compare, or it compares, or it's a pre-test and post-test. Right. The whole point of a pre-test and post-test is to find out what difference such a treatment has made. We give you a test at the beginning of this course, we run you through the course, we give you a test at the end. Now, what do we say? Your scores on this O, post-test, are supposed to be greater than the pre-test. And for those of you who don't make any difference, or it goes downhill, or something else, we have to say this was not a very effective experience. Does that make sense? But there are oodles of loopholes in this. It's called the standard experiment, but it's not called a pure experiment. Not even called a good experiment. It's called a one-shot, pre-post assessment. What's wrong with it? Why isn't it a good way to do research?
There's no control.
Well, no, you got to be a little more explicit. You are dead right that that's what's wrong with it. Now, why is that wrong?
Without a control, you have less assurance that your treatment actually accomplished what you thought it did.
All right. You see, let me show you this, and you're right. Stick with your proposition, but let me give you some scores here. Let's assume we get a 20 and a 40. Okay? Human nature would cause you to say, therefore we know that the treatment made
The increase.
a lot of difference. Now then, if I had an opportunity to show it to you, let me take this out, but I'll also take this out, and then I'll just do these. And let's see what we get. Oops, by golly, that's not terribly surprising. That's what apparently people like that get when they start out, and nothing happens here, right? Okay. Holy cats. What do we got there? Now some people are just so quick to catch that, that they just have a hard time keeping their
That's
mouth
dangerous.
shut. But she has every right to get in it. That's good. I'm glad for that. Thank you. But it's also possible that you're only one possible answer.
Yeah, it seems like there's all kinds of
All
different
kinds of possibilities. Now, we'll give her the privilege of doing the one she's named. What would you like to name?
Some kind of unidentified experience in between.
Some kind of unidentified experience in between here that we don't even really know about, and that's called history. That's called the rival hypothesis of history. Now that may sound funny, but the point here is history is experience that happens along the way. Something happened along the way. That's called the rival hypothesis of history. And it hasn't been ruled out. Now what do we mean rival hypothesis? Rival H. Not to be confused with dog food. What is a rival hypothesis? It's a different way to explain the data. I don't even have an experience going here. I don't even have a hypothesis. All I got is two measurements in time, and I've got to explain them somehow. One of the ways I can explain them is history. Something happened to me. What else could I use to explain that?
Just by stretching the time, things change.
Things change. Now that's history, but it's also something else. Name the something else. Over time, things change.
Maturation.
Thank you for maturation. Now what, you see, we haven't put a time frame up there. Now let's assume that this is year 1, and this is year 5. All right, let's make it a little more interesting. Let's say it's year 7. And this is a very precise measure of bicycling ability. Maturity will set in. How quickly can a child learn to coast on a bicycle at age 1? Oh boy. How quickly can a child learn to coast on a bicycle at age 7? See it? That's maturation. That's maturation. All right, what else could have occurred in this time? Now, I can tell you that in your textbook is a whole list of those rival hypotheses. And it's fun to go through and realize that's how to read it. That's what's going on. What other ways can you explain it? So your design of your study has to rule out those rival hypotheses by ruling in only to your main hypothesis. Now, I'm going to give, at this point, an opportunity for the rival hypothesis of, do you want to name it? Rival hypothesis of, you did name it correctly.
Pretest.
The testing
Pretest
effect.
effect.
Testing effect, all right? Now, what is the rival hypothesis of testing or testing effect?
That you've learned something as a result of taking the pretest, or you've become aware of a situation, and because of your awareness, you are just more attuned to it.
How many of you are aware of what she's talking about? Most people taking any test the second time will do better than they did on the first test, even if there's been no instruction associated with it at all. You become more familiar with the vocabulary, you can read it faster, you will see more of it, it just changes. And since all these O's have got to be identical O's, all testing is the same when you're doing this kind of research. You can't just have, oh, well, we'll test it this way here and this way here. That's too insensitive. You're just not going to have parallels. The tests are going to be the same. You will have a pre-testing effect. It could be as great as that. That's another reason why we need a pure experiment, not simply a test, experiment, retest. Now, I'll show you something here on the board. You see this line? What does the line denote?
Different groups.
Thank you. Different groups, in this case 2 groups. There are designs we can talk about 3 groups. There's a 3-group study. This is going to be a 2-group, which is the more typical. And this can become, with a couple of variables in it, a couple other factors in it, can become a pure experiment. So we're on the road to a pure experiment. All right, so what do we have here now? We have a control group. What is the characteristic of that control group? We have selected them so that they will be equivalent, matched, or exactly the same as the experimental group. Would you believe with white rat experiments that's easy? You can buy white rats in bunches of 50 or 100 from the scientific supply house that are genetically bred so that there's no differences. They're all quite literally identical twins. Now, many of you have an opportunity to do that in your local Sunday school, but assume that you didn't have that opportunity. Does that present some kind of a hurdle to you? Probably. What do you do to solve that hurdle? How would I get a pure experiment to happen in this class?
Matches on the relevant variables.
As close as we could, and it wouldn't be very good. But I can get all the people that have about the same kind of background, you know, maybe one of this, one of this, one of this, one of this. So for everybody here, I've got to find, if you please, the clone, or as close as I can get. Now, there are some real problems there. Real problems there. I hope as we go along you have a respect for the problems of doing impure research. But anyway, if I did have, what would I do? I'd put half of them here and half of them here, wouldn't I? So this is my experimental group, this is my control group. So I call this the experimental group. Why do I call them the experimental group?
And the recipients of the experiment.
They are going to be the ones that I've decided are going to get the experiment. And the control group doesn't. How do you know it's a control group? Because they're going to get the testing, but they're not going to get the experience. Now then, look at this. If I do have a 20-point variance here, and I have a 20-point variance here, what do I know? And I do know something.
There's no
Come on, make a whole sentence. People are using shorthand. The treatment apparently, always guarded a little bit, apparently had no effect. I said, wait a minute, I got 20 points here. That's a lot of variance. Then you come back and say, yes, but
That's 20 points in the control group.
I got 20 points in the control group. What are you yelling about? It doesn't make any difference whether you have treatment or not. Right. Right. Now, if I put this in here, it doesn't make any difference, does it? Now, logically, and this is hard for the old timers to take. I don't need that. It's still a pure experiment. True or false? False. It is false. Why do I need it? Why do I need it? Why do I need this? Because without it, I don't even need this. And I'm right back where I started. Right? Are we there? Because this is the thing I need in order to compare with this. As I say, it's hard for the old timers to take. And when you pull out something like that, you say, oh yeah, the old timers know better. So let's try something else. I'll take that one out. The old timers don't like this one. Is it still an experiment? Is it still a control group experiment? Yes. Yes. If I have done this, got it? In fact, if I haven't done that, I've probably got a chaos anyway. So long as I can randomize my assignments and my subjects are comparable, that forces me back to white rats, right? But as long as those things are correct, I really don't need that first cell. Can anybody explain why I don't need the first cell, this one? Why don't I need that?
Because you're pretty sure that they're both pretty much the same.
The point here is, if this is a random half, and then I just put these people down but I don't test them, and I test them here, and I get a 40, I won't get a 40, by the way. What'll I get? Mistake I made there. It's going to be a 20. See it? If it is a, then what we're getting is a lot of extraneous effect or rival hypothesis. Am I making sense? The reason I don't need it is because, strictly speaking, this is the same phenomenon here. So many times, what we do in an experiment of this sort is, in fact, bring this measurement up to here. Because for all practical purposes, they're not going to be different when they get to post. Yeah.
Would that perhaps even be better because you wouldn't have the testing effect?
No, it isn't really. Only thing you're still not going to rule out testing effect. You're going to rule out everything else. Okay, we're going to take a break and we're going to come back and we're going to put some of this to work, and we're going to see what an experiment looks like in your domain, and you're going to have a chance to write your hypothesis. And when you come back from break, go as fast as you can to starting to write your hypothesis. You do not have a hypothesis unless several things are true. First of all, it is clear what the independent variable is. It is clear what the dependent variable is. And here's the stickler that stops a lot of it. You have to be able to explain how you're going to make the independent variable happen on command. If you take all the green trees in the forest and hypothesize that green trees are taller than brown trees, that's not an experiment, because there's no way under the sun that you're going to get out there and make those trees green. Your hypothesis has to do with something you can manipulate. Otherwise, you're just dealing with more description. It is possible to create hypotheses that sound like experiments. Hypothesis must be there, but it must be what we call a manipulable hypothesis, something that you can affect. So in the process of explaining your hypothesis to your partner, explain how you will get the independent variable to happen on command, under your command. Is that clear? I will stop you from time to time and give you a few more little inputs like that to help keep you on track. And at that point, answer any questions that you've accumulated. But if you want me to come around the group, wave your hand, I'll try to come around.
Is it okay to include in your hypothesis the measure that you would use to...
At least make a reference to it. At least make a reference to it. In other words, it ought to be clear. For example, I was just working with an individual on the issue of such and such an experience will improve satisfaction. Satisfaction is one of those things that is especially difficult to deal with because it's not even as flat out as angry or happy, because it's always a comparison between expectation and outcome, satisfaction. I was expecting a lot and I didn't get it, therefore I don't have much satisfaction. Oh yeah, I learned a lot, but I was expecting more. It's a really tough one. You've got to take very seriously that the dependent variable has got to be either contextually identified in the statement of the hypothesis, or at least promptly defined. Now obviously in the writing of section 3, you're going to have the hypothesis, then you're going to have whatever amount of space it takes to operationalize that treatment and explain in great detail what that treatment is. And that's typically called the, quote, independent variable. And here's the description of the independent variable. You always put that in terms of what you're going to do, and what you're going to have other people doing, and what resources you're going to bring to bear, and so forth. And that's the descriptive job there. You haven't described the living daylights out of that thing. Remember one of the rules about how much you write, and how thoroughly you write, how practically you write? What's the rule? So that another person
Can repeat it.
can replicate your studies on the basis of what you've written. That requires a great deal of thoroughness, all right? Now, the other thing that you've got to be profoundly thorough about is your dependent variable or variables, which need to be spelled out in terms of what you're going to measure and how you're going to measure it. After that comes instruments, where you go further and say these are the instruments, or at least name the instruments you're going to use. You can use standard instruments, you can use homemade instruments. If you use homemade instruments, you have an additional problem of building them and validating them. But in this study, in this exercise, I'm not going to get too precise about how much detail you do on defining.
So could your dependent variable be an increased score on such and such a scale?
Surely,
Okay.
surely. But that doesn't excuse you from explaining the instrument and the score. What kind of a score about what? Yeah, so your statement of the dependent variable could say such and such an independent variable is hypothesized to result in an improved score on the Johnson & Johnson 7th grade reading scores, reading instrument.
Okay.
In other words, you can actually name the instrument in the hypothesis in a case like I just used.
Great. Good. Thanks.
Yes?
Regarding, can both the independent and dependent variable be a test like that?
Well, now, wait a minute. How would you use a test as an independent variable? The reason I'm asking you back is because there are some strange and wonderful circumstances where it just might be. But I wanted to get you to say that rather than me.
We're arguing his hypothesis in the independent variables attending a marriage enrichment seminar.
Attending marriage enrichment seminar.
I was thinking both the independent and dependent variables. Is there such a thing as too atomistic, too narrow?
Oh, sure. But don't worry too much about that right now for this exercise. Okay, now that's the experimental treatment. He's going to have some people attend this marriage enrichment seminar. Tell me the dependent variable.
It will show an increased score on the Locke test of marital harmony and satisfaction. It's a standardized test.
Does that sound like a hypothesis to you? Come on, live dangerously.
Yes.
Yes. Okay, anyone want to say why it's not a hypothesis to really show your genius? Good. Good. That was the right answer. Yeah, now what was the problem?
We're just thinking of, so he's attending a marriage seminar?
Yep.
And then show on the test.
Yep.
Is that a...
That's not a test at both ends. That's an experience followed by a test. Remember our model? You'd have some kind of a standardizing score to find out what this group of people looks like before the experience. And you'd provide the marriage enrichment seminar, which is the X, and you'd do the test again. Am I right? That's the only way to do it. Now the problem is you can't sort out how much you affect from the testing. And you can't sort out a lot of other things, so it'd be kind of nice to have a control group on that one. People that don't take the marriage enrichment seminar. The problem is you'd have to also be able to assert that they are very much like the people who did. And one of the surest ways to find people who are different is to find a group of 50 people and tell them that 25 of them can go into the marriage enrichment seminar and the other 25 can do something else. Why will that produce two different groups? Very different groups.
Because of choice.
They have the choice, and so you can get the ones who are eager for this, motivated, and so forth, and know they have something to learn. And then you get the other group, the jolly boys, who want to go out and have a party. So then you're not really anywhere near matching the groups. But that's the real world. So quite often what we have to do is make the best of that kind of situation.
So I was
thinking of handling that problem
Good?
by getting the total group who are willing to attend
Yep.
and dividing it in two and telling them, these people will take it now, and then later on, the second.
That's
group will
one of the
take it.
better solutions, is just give them two different sets of tickets. Do you really get the importance, I want to make sure of this, of understanding that the independent variable is the treatment? Is the treatment. That's why you have to be able to describe the independent variable as something other than taking the course. Because that's not much of an independent variable. What specifically is that course supposed to be doing? And quite often when we say, well, we're just going to put them through this experience, like your marriage enrichment seminar, you've got to be, in your hypothesis, much more forthcoming about what the nature of that experience is, or what the core of that experience is. In other words, what makes that marriage enrichment seminar differ from the other 5,000 that are out there? Because, you know, it's a little bit like saying, taking a train ride will get you to Portland. There's an interesting hypothesis. Taking a train ride will get you to Portland. Is that testable? It is. It is testable. The problem is that the independent variable has not been defined. Consequently, we will test that variable and put a whole bunch of people on a whole bunch of trains. Some of them will get to Portland. So is my hypothesis tested or not? Well, not very well. Now, if I say getting on the right train to Portland will get you to Portland. See, I've defined the independent variable. Getting on the right train to Portland will get you to Portland. You say, well, that's obvious now. Well, if you don't do it that way, it's nothing but a silly game. You've got to define the independent variable in terms of what exactly this experience or activity or operation is doing for people or to people, or how they relate to a function. The other thing, of course, is that you've got to take very seriously finding the instrumentation for the testing of the dependent variable. And if you don't have anything that you know of, you better give us some sample items for an instrument that you're going to build. What I wouldn't want you to wink at is the need for getting explicit about that instrument. Now, if you know instrumentation well enough, or it deals in an area where you're already familiar with instruments, you're quite free to name an instrument. You'd be surprised how many instruments I'm familiar with, by the way. So I would like to see some that are realistic. Or indicate an instrument that you need an instrument that will deal with matters like these, and list the matters, and then give some sample items of what you think that it ought to look like, so that I know that you know that you can build it, if you had to build it. Tomorrow I'm going to show you, thank God, praise God, from whom all blessings flow. Campbell and Stanley came along about 30 years ago with a whole rethinking of independent and dependent variables, and particularly the issue of rival hypotheses, and came up with a beautiful reanalysis that just took the old thinking and turned it on its head. So we now have what's called quasi-experimental studies, which are designed for the real world, where you can't get perfection, but you can approximate perfection with known gaps. And then if you know the gaps, then you can close those gaps other ways. And that's what quasi means. Quasi doesn't mean almost as good as or cheap substitute. Quasi simply means it's quasi-experimental because it is not pure experiment, but it is responsible experiment where the gaps or the holes are so well understood that you can be sure they're plugged other ways. The point of it is, if you do this one, the pure experiment, and you kind of write this down and treat this as something that you're always going to have ready. That's the pure experiment, as long as this is there. Now tell me what this is. Randomization of assignment to a control group or an experimental group, an assessment or observation or testing, followed by a treatment, followed by a retesting. And this group is only the testing. That is it. That is the pure experiment. And science has ridden on that experiment model for 2 centuries. But it isn't very practicable, except when you're working with white rabbits or rabbits or other highly controllable creatures capable of having null experiences, being left in the box. Let me tell you something about human beings. They don't tolerate very well being left in the box while somebody else is going out and having the carrots. Okay. Tomorrow, you're going to read up, look at quasi-experimental, recheck experimental chapters, look at your hypothesis, keep trying to clean the thing up, make it a little more germane, make it a little bit more precise, and probably in most of your cases a little bit narrower. Try to get all the fuzzballs out of it, so that you're not, studying a gross thing here that you're going to do. You're going to do a big old thing here for people, and then you're going to get this foggy stuff out here down here. Get rid of the fuzzballs and the independent variable and the fog banks and the dependent variable. Pin it down. Okay. The next thing you can do, and it's very profitable, is write out the procedure for implementing the independent variable. Describe how you're going to do it. Now, if you get really ambitious, start in on chapter 1 and treat as the first matter of business describing your hypothesis and where it came from. Let me remind you now of the parallels we've done in terms of these 2 presentations. What is the guidance mechanism for a descriptive study? Descriptive study. What is the guidance mechanism? Research. Questions. What is the guidance mechanism for an experimental study? Experimental study. Research. Hypotheses or hypothesis. For the purposes of this study, I'm only asking for one hypothesis and to follow through with that one hypothesis. That one hypothesis will not reflect everything you discovered, learned as outcomes from your first study that you've now hypothetically done and have the findings, right? It will not deal with all those findings. It will deal only with one focal point within those outcomes. Someone was up here a little while ago saying, well, I got so many different kinds of outcomes from my first study. I have to build lots and lots of hypotheses. And I said, no, that would wear us all out. Just pick something interesting and valuable and build a hypothesis around it. I don't care if it doesn't represent your whole previous study. That's fine. You can get started writing on that stuff. So section 1 and bits out of section 3, like the independent variable. You'll be down the road a bit. And after I give you some feedback on this tomorrow, I can tell you probably a little bit more about where some of the sore points may be that you want to think about for the next time. We will give some time for response back to you on these first papers, so we'll take a look in tomorrow and look at this just to cement all of this. Then we're going to put it away and put it under you and sit on it and don't get it out again. I will also tell you something else. I'll tell you this tomorrow, perhaps just as well, but I might as well now. Some of you in your first paper will have a substandard paper to put you on the road to a bad grade in this course. Standing offer, hear it closely. Don't, D-O-N-T, rewrite that paper now. If you do, it invalidates this deal. I give you a deal. You rewrite that one after you've written your third one. Then you can rewrite any one you want. And I'll take it fresh and throw away whatever your score was.